Welcome everyone. Please have a seat. Can you all hear the mic? You want to select channel 0 for English. So welcome everyone. Welcome to the 2019 Innovation Summit. So it is our pleasure here to launch the sessions with this collaboration-oriented session. So I will introduce the speakers for this panel today. Enric, why don't you introduce yourself?
Hello, I'm Enric Lopez. I'm AI Director for Microsoft France. So basically, I'm driving everything related to AI and the Microsoft France subsidiary. Should it be driving innovation? Should it be engaging in the more responsible AI, or driving upskilling, reskilling around AI, and also working on AI for good initiatives?
Good morning, everyone. Alex Peltier. I'm an investor, venture capital investor. We invest in B2B startups, Series A, Series B, and basically our thesis is to invest in startups that help large enterprise transform themselves.
Hi, everyone. Thank you for giving me the opportunity to be here. I'm the Guillaume Vercante, the new technical director for Carrefour in France. I'm in charge of all the construction of our stores and the maintenance of our sets.
Thank you.
Good morning, everybody. My name is Elena, Schneider Electric, in charge of strategic alliances and part of Schneider Digital.
Thank you all. And a few words about myself. So my name is Rodolphe Elio. I'm in charge of innovation for Schneider Electric. So we do collaborate a lot with startup companies, with other large companies like Microsoft. And it's my pleasure today to have this panel with me on board. So let me give you an overview of what we will discuss today. We're going to first have a panel, about 20-25 minutes, where we're going to discuss what is AI and what it can bring to you customers. And from there, we'll show examples of how do we collaborate together with Microsoft, with VCs, with startup companies, to make AI happen. And we'll have a couple of startups joining us on stage a bit later on. So let's kick this off. And I'll start with a first question for my panelists. Okay, what is AI? Can we give the audience here a definition of AI and what it can be used for?
I start? Okay. I will start with a very basic explanation. I will not go into mathematics or algorithmics. I think if we want to have a good definition of what is AI, let's take a look at what AI can do for us. Basically, and I will use some, I would say, human terminology, but that's more intuitive to understand. AI first can resonate. It can resonate. Do reasoning by using data that you provide, identify patterns in the data, and then have insights, and then let's say suggest or drive a decision. The second thing that AI can do is understanding. It completely understands the environment. They can understand the faces, they can understand the emotion, they can understand the gesture, they can understand object, and AI can understand language. And the third C is engaging. By reasoning and also engaging and understanding the environment, you can engage more naturally between human and machine to have not only conversation, but to interact. So reasoning, understanding, and engaging.
Thank you. Alexandre?
Yeah, I would pretty much agree with that. I guess the one thing I would add is to say, well, look, in the end, AI is really about teaching computers to somehow behave like humans or understand basic things that humans can do. And because artificial intelligence is quite far from human intelligence, it's really good at doing very basic things that are boring for us humans. And so it calls upon feeding computers with lots of data, the right algorithms to teach them, telling them when it's right or when they're making the right or wrong decisions, and letting them learn to emulate what humans can do. But again, at this stage in time, very low level in the end, if you think of it.
Okay, so thank you both. Can we give some real-life examples of AI applied to real customer problems? And Guillaume, I know you have some ideas.
Thank you. And you know, the dream maybe for common seller like us is to know in advance what the customer wants and what the customer wants to buy, for sure. Because the entire supply chain would be simplified, storage reduced, and for sure cost reduced. Let's talk about building, a subject that I know better. We need AI to aid with the control of our technical installations. The first one is for sure the comfort of our employees and the comfort of our customers. And for sure the product durability in our stores. With, for example, 40 degrees outside, you can't have more than 26 degrees inside, or you sell melted chocolate. The second objective, maybe, is to ensure a fine management of energy consuming. In order to reduce the electricity bill, we have in France more than 1,050 supermarkets and more than 200 hypermarkets. That means a lot of square meter. The financial impact is enormous for us.
All right, thanks a lot. Alexandre, I know you have other examples from what you see on the market.
Yeah, so obviously as a VC, I see tons of startups every year, about 1,500 submissions that we receive, and about 500 that we see every year. So a lot of them cover AI. Sometimes it's relevant, sometimes it's not. It's not really about the technology, it's about what it solves. We see AI, it's pretty much everywhere. I mean, think of your everyday life. I mean, you see autonomous driving, it's a genuine application of AI. We see it in medical diagnosis, for example, where we're making doctors' life easier. It won't replace them, it's just making it easier. It facilitates, it accelerates the treatment of medical files or medical imagery. You see it, and I mean, there's tons of applications, be it your supply chain, making it more efficient, making electrical grids more efficient, because what AI does in the end is you're asking the computer to make use of tons of data that the human brain cannot use. Computers are just smarter from that perspective, is they can deal with so many more data sources and so much more data than we can, and that technology is available today to process that data and provide recommendations, and that augments us as humans in making decisions. So they're really, that's what AI is for. So it's everywhere, it's going to be everywhere, and it's a good thing.
Maybe I can provide an helicopter view of what AI can provide in this digital transformation. If you want to summarize, AI can definitely change the way you engage with your customer. If you have, for example, the bots in mind, everything related to a personal assistant, but also the way that you will completely change the customer experience. But also AI will empower every employee within the organization. If I provide you with automated translation, if I provide you with a research engine, knowledge mining where you can find information within your document, if I provide tools that helps you do some activity, should it be maintenance, and it's also true for vertical but horizontal process. And definitely can improve your operation on a vertical basis, for example, predictive maintenance, but also if we take marketing activities, better targeting, micro-segmentation, better understanding of your customers, propensity model to sell new services, or HR process for hiring and matchmaking. And also AI, of course, can completely change your business model, your services, and that's the fourth part that AI can completely transform the organization.
Thanks a lot.
All right, and I guess I will add just on top of what has been just said and give you a little bit of Schneider perspective on how we do things with AI. So we'll look at it from two different angles. The first will be internal, and this is what Alex mentioned. How do we enhance and enable the employees of Schneider? And the second one will be external, which is everything about creating digital offers and services for our customers. So for the first one, for the internal one, giving you just one example, we will enable and enhance the way our salespeople and our field service technicians are working. So here, this is what we call a digital opportunity factory within Schneider. Based on the data that we have, you all heard about CRM systems and Salesforce. So based on the data that we have in Salesforce, we will be able to apply the AI on top of this data in order to better target the installed base. And from the other side, so if I give you an example of external AI-driven solution, it will be one of our solutions that is called RealLift. So here what we do, we provide predictive maintenance to the technicians who can control remotely the pump of oil and gas that is somewhere there in the field. So we collect the data, we analyze this data, and then on top of that data, we are able to tell the technician that the pump needs a certain spare part in an hour or 2 hours or in days to come, and the technician is able to come with the spare part. So those are two very concrete examples on how we do it.
Thanks a lot to all of you, and I'm going to summarize it in 3 points. A better customer engagement, new products or a better performance for existing products, and improved operations, reducing your OPEX basically. So that's the whole range of what AI can do. So that's what it can do, but we know that whenever we want to make it happen in practice, things got a bit hairy. So I'd like us to share a bit our reflected experiences on what does it take to deploy an AI project, and how, being together with different partners, we can make it happen faster, better, more efficient, whatever. Any thoughts?
Yeah, so I can, if you wish, I can
Go ahead.
Jump in. So while we were going through our digital transformation with AI and data-driven decisions, I would say we discovered 3 main things. The first one is we have to know what is it that we are trying to solve. What is the use case? What is the customer problem? What are we focusing on? That is probably the most important lesson learned that we had. So working together with the customer, finding the right use case, finding the right problem to solve. The second one is skills, and I think Alexander as well will be able to talk about that, but skills and people, data scientists that we need in order to make the solution happen. So do we hire them? Do we develop them internally? Do we have them on the market? Do we outsource? So that is the second one. So the second one is skills. And third one I would add is, once you have a solution, an AI-based solution, where the difficulty comes in for us is how do we identify the right business model, the right operating model? How do we sell? And what do we need, right? So it's not all to have a solution, but then how do we make it really happen? Execution is key. So those are the 3 things we've discovered during our journey.
Thank you, Elena.
Well, I will jump into what you just stated. I think definitely the finding the right use case is the foundation. Most of the time when we discuss with different customers, they identify the use case, but they are looking for the ROI. What's the return on investment? And I think we have to have in mind that it's not always an ROI in terms of money, in terms of cost. Maybe you have to identify the value that this use case will bring. Would it be improve efficiency? Would it be improve customer satisfaction? Would it be to increase our own new services and value that we bring to our customer? It's really important that we define the framework of the use case and the one that we want to tackle with AI. And then, after you have identified those use case and the value that you want, align everybody in the room toward that objective. When I say everybody in the room, you have to have people with this business knowledge and the people more on the AI knowledge and the data science, and having the same focus. When I say that, it's that you cannot have data scientists say, hey, my objective is to build a right model, and the other one is a business objective, which is reduce the cost or improve the efficiency. Everybody should be tied to that value. And then collaboration is key. And to have a great collaboration, I think having the same level of understanding of what is AI, what does it mean, and it's related to the skills, is really important. Because if you put a data scientist in front of the business professional, most of the time they will not be able to discuss. People manipulating data do not even know what does that mean, this kind of pattern that they have identified, for example. When you're doing computer vision, it's pretty obvious that you can recognize objects, but when you are doing machine learning, the pattern that you have doesn't make sense for you. And on the other hand, people from the business perspective, they need to understand what does that mean that they want to translate their business objective or their business pain points towards the data that they have. So collaboration is something crucial. And in that collaboration, it needs to be agile. You cannot think about a project, throw it through the wall and say, hey, let's develop and go in that, let's say, tunnel effect. You give it to the data scientists and to developers and they will develop. There needs to have an agility, a kind of DevOps way of working. We call it MLOps, machine learning operation, to have a more agile between business and development and data scientists.
Clear. Guillaume, I know you. You see, Alexandre, sorry. I know you see a lot of things yourself as well, and maybe it will be interesting to have your experience in terms of how do startup companies, especially, tackle this agility question.
Yeah, it's a key thing. So, the same for, as much as it's true at Schneider that you need to figure out what problem you're trying to solve, it's the same thing we ask startups that we see in deal flow. And when they come to us, we say, okay, what problem are you solving? Whether you're using AI or whatever technology is not really relevant. It's what problem are you really solving? And if you're solving a business problem leveraging artificial intelligence, the key thing then becomes, okay, what partnerships are you building to solve for that, and what skills do you have? And so partnerships to me is, when I see startups, they need to be working with genuine business problems from the real world, and that's working with corporations. Running AI calls for a lot of technology. I mean, the data processing, etc. You need platforms. This is where players like Microsoft come into play, and if startups aren't working with them, I think they're probably missing out on something. And then in the skills, and what's the beauty of startups, and the reason why AI startups are interesting is because they're founded by outstanding people that are trained in mathematics, algorithmics, AI, and they build teams around them that are just exceptional. And I think the value of an AI startup today is the quality of the team. This is what's going to make the difference, because in the end, you can do this. You can do this within your enterprise, within your corporation. But the beauty of startups is they're extremely focused on achieving a specific business outcome against a very specific business problem. Because they do this on a very specific level, very verticalized, they need to be working with corporations, and lots of corporations on repeatable use cases. So that's what we look for. But the skills they have are extremely important in terms of not only the math and all the science behind, but also the understanding of how it works. Because in the end, and going back to the point you made on skills, I guess, if we look at our kids, they're going to be working, there's going to be AI everywhere. And the beauty of this is basically the low added value tasks are going to disappear. So boring things like going through the cash register is going to disappear. Driving a car, which can be boring, especially in traffic, is going to disappear. And our kids will have to, doing fraud analysis, things like that. This is going to be powered by AI. But you'll need the skills to understand how it works. So it's not only about programming all of this and doing all the math. It's really about understanding, because the output that the computer gives you need to be able to understand it. You need to be able to understand it and make sense of it. And the explainability of AI, and especially in technologies like deep learning, becomes even more so important. So this is where upskilling the population overall is super important on that soft part of understanding what's that outcome, where does it come from, and what do I do with it. And that's something we cannot overlook. That's going to be a major thing for the next generation of our kids.
Okay, so you're saying basically back to the use case. It's really focused on what we're going to bring to society in the end. I really like the point you made on startups need to deploy, and for that they need to collaborate with corporations, for example. Do we have any examples around this table of past examples of collaboration we have with between large companies and startup companies? And
okay, I can jump in on an example. So, okay. Technology. So the one example that I will give you is an example of us working together with Microsoft on AI for green energy. So here, what we do, so while being in our digital journey, we actually understood that we cannot make it alone, meaning Schneider. We need a piece of technology to make it happen in digital. We need a customer, because we need to know what customer needs. We need to collaboratively work with customers. We also need startups, because this is the crowd that will give us and bring us ideas on how to solve some of the customer challenges we don't know how to solve, who will bring us some innovation. Same for universities and different laboratories, for example. And so to circle back to the question of Rudolf, is what we built with Microsoft and AI for green energy is exactly this. We partnered with Microsoft, we partnered with a laboratory, if I remember well. We partnered as well with a VC, venture capitalist, and startups. And the idea really is one big company is bringing technology, another big company is bringing expertise and the core. We blend it together and we attract the startups with the technology and the expertise. And then I will let Rudolf and Rick, maybe you complement what we did with that exactly.
Yes, exactly. This is the key element. From the Microsoft part, it's pretty simple. We only bring technology. We are a building block company, so we do not even know the business and we do not have the expertise. And Schneider is bringing the expertise. And on the other hand, we have those startups which are at the cutting edge of innovation. Mixing all that together and working on clear business case that you provide from the Schneider, that you can solve with your solution and from the startup, and accelerating with some technology, accelerating with some marketing, business to business connection, and of course funding if it's needed. This is exactly what is our intent in that program.
Thank you both. And so I'll share a bit more details on the joint program that we built together with Microsoft and Schneider for the past almost a year, actually. So the intent was really to create this space for collaboration, bringing together technology, expertise, access to customers, and a real focus on a business case. So what we did in earlier this year is to launch really a call for applications for startups to join the program. So we ran a call. It was really a massive outreach out there. And the proposal for startup companies was, okay, join us for a few months. And this means we're going to work all together with Microsoft, with Schneider, with these startup companies, with a lot of workshops working together on finding out how can the technology brought by Microsoft, how the business expertise brought by Schneider can help you startup companies to grow and also to solve problems that our customers have identified. So we received a number of applications from all across Europe, and we had a selection process, and out of there we decided to support 6 companies that will be welcome starting October 7 next week in our headquarters in Paris. The intent is for the next for upcoming months until January, really to work very closely and with the idea of bringing something together to market in that time frame. So as part of this program, I'd like to welcome on stage 2 of the 6 startup companies we've been involved with. So gentlemen, if you please step in. I'm going to give you a mic. Yep.
Thank you.
So why don't you share in a few minutes who you are, what is your startup company focusing on, and what do you expect from this program with Microsoft and Schneider Electric?
I'll start.
Go ahead.
Okay. So thank you very much. For us, it's an enormous pleasure to participate in that program. We have actually partnering with Microsoft since 2014. And what we do expect is to spread our AI solutions as a game changer on the energy market.
Can you share some more details in terms of the what is your solution going to bring to customers? Which customer are those?
Okay. At Smartif, we believe that renewable energy has been a game changer on the way energy is produced, coming from a more centralized energy model to a distribute. And to handle this distribution of energy, it's mandatory to be capable to diagnose, control, and monitor those energy assets. Actually, artificial intelligence is helping us on that, and our customers. And I won't say it is artificial intelligence, I would say much more it's artificial routine. Because artificial intelligence is capable to monitor 1,000 wind turbines, diagnose, and provide insight to the actual intelligence, which is our teams and our customer teams. The people is who's bringing the final intelligence in order to take decisions on what assets should be maintained or improved or inspected properly. So we provide solutions based on machine learning and deep learning in order to monitorize energy assets and provide many different insights to take decisions.
Very clear, thanks. Can you share in a few words your expectations for this time to come with Microsoft and Schneider?
So, Microsoft, it's a worldwide leading company on software, so we are working with them since 2014 on Azure cloud services, so it's well presented. And in Schneider, it's one of the leading world companies on the energy market, on the industrial market, on smart metering, on control of industrial applications and energy assets. So for us, it's like a dream. It's like being with two great partners that provides market intelligence, awesome technology, and we can partner with them in order to boost our small startup worldwide.
Thanks a lot, and thanks for the compliment.
Hello everyone, I'm Laurent Laparra from EcoAdapt. What we try to solve with our solution is predictive maintenance for electric rotating machines. That problem has not been solved for many years. We still have a lot of failures, typically 3% per year of unplanned outage for electric rotating machines, so that's a terrible loss of productivity. What we do is we use current sensors and a small equipment that will analyze at a very high frequency the electric signal of the machine, and we can detect a very micro variation of speed or torque, and we can infer that there may be the onset of a problem with a bearing or a shaft alignment problem or electric problem inside the machine. So this is what we do. And so far that's proven to be working much better than all the alternative technologies that have been developed over the last 20 years. Now we're really happy to be here because we feel very well welcomed. We understand that there's been a shift in large corporations. Today, the Schneiders or the Microsoft of the world want to welcome startup for their agility, for their very high-level team, as it's been said before. And two, we get a reach on the market as a startup, I cannot afford to hire 100 sales guys to run the world and meet every factory director, right? With Schneider, with 1 or 2 person, I can understand very quickly who are the 10 plants in the world that need most our solution, be it in New Zealand, in America, or in Asia, wherever in the world, and we can all just do that very quickly. And with Microsoft, of course, we access to top-level experts. That's going to enhance the way we're going to industrialize our product, because we've been able to develop small-scale product, but when we're going to reach to hundreds of thousands of machines, it's going to be a different story. And there we need to scale with scaled already partners such as Microsoft.
Fantastic. Thanks a lot. I think it's time for a Q&A with the audience. So if any of you in the audience has some questions you'd like to ask any of the panelists or the startup companies, please feel welcome. Anyone? Okay. No question then. Oh, there.
You mentioned about the monitoring of equipment to analyze the data to give you better data sets. How do you see the divide between using real-time AI and historical AI data to give you those kind of data sets and that kind of information?
I can take this one if you like. I'll fall back again to the use case and the thing we're trying to solve. In our situation, we look at failures. Failures rarely develops instantaneously. Or if so, then it doesn't mean anything to predict it. Because if I'm telling you, in 5 seconds, the machine is going to break down, what are you going to do? Nothing. So we look on a day-by-day basis, because the typical development of a failure is about 1 to 2 months. So we don't exactly need real time. However, we multiply different recordings under different aspects of the functioning points of the machines, and then we can have a bit of lag to do the whole processing of the data. So in our solution, we don't need exact real-time artificial intelligence.
In our case, it's different. We work with SCADA data coming from the wind turbines. So we use the historical in order to look for patterns. The good news are that there are patterns in failures, but you need to perfectly tackle and perfectly label which kind of failures in order to say to the algorithm, hey, learn that just before this point, it has happened something. So our goal is to predict failure 90 days in advance. Otherwise, if I'll tell you tomorrow that your turbine, or today that tomorrow your turbine is going to break down, you have no time to do anything. So our challenge is to shift 90 days in order to program cranes, spare parts, and almost everything. The good news is there are patterns in failure, especially in fatigue and rotating machinery. The bad news is not always. There will be always unexpected failures that, with current technology, the algorithms cannot see yet.
Thank you both. Any follow-up questions or any other question from the audience?
Hi, thank you everyone. Just wanted to know, are your algorithms to predict failures mostly data-driven or physics-driven? Where do they start? They start from the, let's say, physical properties of the machine, or they start from the statistical analysis of past failures?
So I would say it's a combination, it's an actual combination of both. So data-driven provides insight, but if you don't understand the physical behind the data, if you're not having a team or partnering with your client that explains you what those data means, it ends to be useless. So what we do at our company is to combine people coming from the energy sector, more than 15 years working on maintenance of wind turbine assets, and people coming from the computer science and mathematics in order to mix both worlds to understand and to improve. Because we are continuously improving the algorithm by saying, hey, we haven't noticed that pattern. We haven't seen that one.
I can complement on that because we start with the deterministic physical model. It's not like we need thousands of data. We see so many startups saying, okay, give me all your data. I'm going to connect to all your PLC, all your SCADA, get all the data. There's been a lot of experiments. I just give an example of one that is really striking. At RATP in France, in Paris, there's the metro operator. They said they applied that approach. So they collected like every possible data from all PLC and small automation system, right? And at the end, they were looking at the problem of the doors that do not close properly. It's one of the major problems for a metro operator. And at the end, they came out to say that they could predict with maybe 3 or 5 minutes in advance, and there was one value that was making 90% of the prediction, was the actual failure state of the door controlling automate. So at the end of the day, they didn't learn a thing. We had a totally different approach. We said we're going to start with the physical model of the machine. For example, if you have a bearing that has 8 balls inside it, I know that if I see in the spectrum of the signal something that appears at 8 times the rotating frequency, there's a very high chance that it's related to a bearing problem, right? We do 80% of the work based on deterministic model. If it works, our solution, it's not because we took years to learn from thousands and thousands of machines or that we are just lucky. It's because physically, if there is a failure, we know how it's going to behave. But then we still need to add a little bit of artificial intelligence on top of that. And I will just put it that way. No two machines out of the factory line are the same, right? There's a lot of very small variations in the real world, and that's the limit of the theoretical model. So we need to add a bit of artificial intelligence to kind of mitigate those little differences and make the difference between what is acceptable and what starts to look like a failure.
Thanks a lot. We have time for one last question from the audience.
It sounds like a lot of what you're talking about is supervised learning. Do you use any unsupervised learning methods?
Yes, that's a very good point. Especially in predictive maintenance, if you do only supervised learning, what does it mean? It means that you need to wait to have occurrences of faults. And in some situations, it can take months, if not years, right? Who is willing to wait 3 years to learn on 50 cases of failures before you know how it behaves before the failure and you're able to detect it for the next time? Nobody really wants to wait that long. So what we do actually, we do not unsupervised, but we do semi-supervised learning. What does it mean? It means that if the machine is okay, you already label the state that the machine is okay. So you can say, okay, I'm learning a couple of weeks when the machine is normally functioning. And then the semi-supervised algorithm will tell you if you are out of the boundaries that has been learned on the normal state of the machine.
In our case, the solution is slightly different. Usually, the algorithm must be customized for each wind farm, or sometimes for each single wind turbine, because they behave differently depending on their place. Imagine a mountain, the top and the bottom. And it's indeed true that for supervised learning, you need to label what happened in the past. And especially new ones, you're having not historical, you're just having data. So what we do in that point is we go for clustering and what we call the anomalies analysis, in which we try to see if the data is behaving differently than the common. Having high frequency data like our partner here is providing would be awesome for us, because it's indeed clear that if you can analyze the spectrum of current, you can see different harmonics that tackles certain problems. The pity on us is that wind turbines not always have sufficient communications and electronics to provide this information. This is why we go for the anomalies analysis, the clustering, and the SCADA database, which is poor than the high-frequency data.
So Rodolfo was actually an idea for you to make those two guys work together.
Exactly. We're going to put you in a room and bring you food and you'll make something happen. Thanks, everyone. Thanks for joining this morning. Once again, it's our pleasure to welcome you to this Innovation Summit. We're reaching the end of this AI for green energy session in partnership with Microsoft. Have a great day, and obviously feel free to come and chat more with us if you like. Bye-bye.
Thank you.
Thank you.